Hey, Algebra 2 fans, here back at Stairs Lair. Now, when we're taking a look at this, we're going to talk about a specific kind of pattern here, arithmetic sequences, right? So what we're going to start diving into, and maybe you saw some of these on the Math Excel assignment, some of the worksheet, the pattern was a little bit hard to find. If something's an arithmetic sequence, then the pattern is going to be a lot easier to find, right? So just abbreviating arithmetic sequence here. All an arithmetic sequence is just a pattern of numbers that has a common difference. Now wait a second. You might be saying, hey, how does that help us? I have no idea what a common difference is, right? So let's take a look at what a common difference is, right? A common difference right here is just this. It's the number that is added. That's a very important distinction. The number that is added. Could be a positive number. It could be a negative number. To get the next term in the pattern, right? So common difference is always adding, right? It doesn't matter. Maybe here's a pattern here, and I might ask you guys the following question. Hey, what's the common difference? And let's say that here's the pattern. 5, 3, 1, -1. The common difference is what we add to each number to get the next term of the pattern. So the common difference has to be -2, right? Common difference is always adding. That's a very important distinction, right? Could be adding a positive number. You could be adding a negative number. Now, we worked, and I know a lot of you guys had some questions about this. I was happy to try, and hopefully I did, clarify some of those with the Zoom meeting that we held on Wednesday night. But what I wanted to do is I want to talk a little bit more about this idea with an arithmetic sequence as it relates to two different things, a recursive formula and an explicit formula. All right? So let's take a look here at just doing it with a recursive formula. We recall that a recursive formula has two different parts. It has my first term, and the second part is just my previous term. Now, with it being arithmetic sequence, we know it's adding the same number each time. That's the only way arithmetic sequences can happen. So it just has to be adding that common difference, right? So let's recall that that's what the D stands for. It just stands for the common difference here. All right? That's really the recursive formula. We'll give a pattern here and we'll take a look at that. But some of you guys had asked, hey, how do I find this explicit formula? We really didn't have a lot of questions on finding the explicit formula in previous assignments so far, but that's really what I want to focus on today. All right? And we're just going to use this formula here. So please, this is an important formula here. A sub n equals the first term plus the quantity of n minus 1 times d. So I'm going to go ahead here and see if I can. Let's see here, we'll put that in red. We'll put this in green. Put this in purple. And then I'll do this one here in black. Now let me be honest with you guys. There's some connections here with things in the pattern, and I'll explain this more, but in this formula there's two things that are two sets of things that are connected. these two right here are always connected, right? The answer for the first term and the first position, okay? Those are connected. If I say, you know what, I don't have the answer of the first term, maybe I have the answer of the 7th term, then this would be minus 7 over here, right? So they're connected. These numbers, these ones are connected, right? Same idea, and you might get an idea of this, but right here, these two are connected, right? So if I'm trying to find the answer for the 23rd term, then I'm going to want to put 23 right here, okay? Let's take a look at one pattern here, and let's write it in both of these situations here, all right? So here's the pattern. I'm just making it up, not trying to be too difficult here, but let's go 5, let's go 10, let's go 15, let's go 20, let's go 25. All right? So if I was to look at this with the recursive formula, right? Remember, I need both lines for that to be my answer. The first part, in no particular order, a sub 1, my answer for the first term, that would just be 5. Now my answer for all terms after that would just be whatever the answer for my previous term is plus 5. See how my common difference right there is just plus 5 all the way through, right? So that's where this 5 is really coming from right here. All right? Now, when I do the explicit formula, this is really just y equals mx plus b, okay? That's really what it is, right? If I said the first position, that'd be like x is 1, then y would have to be 5. X is 2 for the second position, y would have to be 10, right? So the explicit formula really is just a y equals mx plus b formula, all right? Now, we could plug some numbers in here. So let's just kind of go through. A sub n, right? That's really like the y, right? So we could just say y equals or a sub n equals, right? If we were actually trying to find some information out, we'd have some more info. All right. So when we're looking at this here, it says a sub 1, well, my first term was just 5, right? So if I go back to this pattern, first term was 5. Let's see here. Perps McGurps. I got a plus sign there, and I just have an n, right? That's typically what we view as the x, so n minus 1. And then my common difference would be 5. It is just a coincidence here that these two 5s are the same. Okay? Just a coincidence. Not always will they be the same. Alright, so let's see if I can simplify this here. Looks like I can distribute the 5 that's connected by multiplication. Okay? Notice there's a plus sign there. So I have 5 plus 5n minus 5. Looks like I have some like terms here. And so a sub n equals 5n. Usually, when we have something in y equals mx plus b form, we do have a y-intercept, right? There's always a number that's added or subtracted there. Most oftentimes you will. This is just a unique scenario in which it doesn't. Okay? So that's something that happens right there. That's an explicit formula. And those are the explicit formulas that we're really going to predominantly focus on here for the next couple days. Okay, so we have our recursive, we have our explicit. Let's do some more work with this explicit idea. All right. So again, let's just write the formula down so we don't have to go back and revisit it. But the formula was a sub n equals a sub 1 plus the quantity of n minus 1 times d. All right. Now, again, I was telling you guys that these two terms right here, they have a special connection along with these two. So I'm going to give us a couple different scenarios in which we might see, and let's see what happens here. All right. So let's say that I have this pattern here, 3, 7, 11, and then I'm just going to let it go there, and I'm going to find the answer for the 20th position. Right? I'm going to find the answer for the 20th position. Okay? Now think about this. One thing I could do is I could keep this pattern going, right? I could say, okay, 15, 19, 23, and so on, to see what happens here with that. However, what we're doing though is we want to just find out what happens at the 20th position. So what we could do is we could use this formula. I want to find out what the answer of the 20th position is. So I know that it equals the first term plus whatever position. So notice n is the position number minus 1. And then it looks like it's just times a positive 4, because that's the common difference, right? So if I'm thinking about this here, I have all of this that I could solve. I have 19 times 4, that's 76. 76 plus 3 is just 79. So my answer, my 20th position, I could keep that going, but I just use my explicit formula to figure that out. All right, I'm going to take a pause here and upload a second video.